116 earthquakes struck the same square kilometer of California desert on Sunday, under a volcano most Americans have never heard of and almost nobody is watching. Coso last erupted 40,000 years ago. It has confirmed molten rock beneath it, a power plant drilled into its roof, and exactly one seismometer keeping track of it. The largest quake arrived at 1 in the morning, 4 days in, after the swarm had already appeared to die. Here is what the data actually shows, and what it cannot. Between Thursday the 20th of August and yesterday morning, a volcanic field in the California desert produced 208 earthquakes. That number comes from the United States Geological Survey's National Catalogue, counting every event recorded within 35 kilometers of the center of the Coso Volcanic Field in Inyo County. Almost every one of them came out of a single cluster about 10 kilometers northeast of Coso Junction, at a depth of roughly 2.5 to 3 kilometers. The rate is the first thing that matters. From the 1st of August to the 19th, that same search area produced 96 earthquakes, a little over 5 a day. From the 20th onward, it ran at about 42 a day. That is 8 times the baseline. On Sunday alone, the catalog logged 116 events, which is roughly 23 times a normal August day at Coso. Here is the statistic that should stop you. From the 1st of January through the 20th of August, nearly 8 months, the Coso area produced 2 earthquakes of magnitude 3 or greater. In the 5 days that followed, it produced 4. This swarm doubled the entire year's magnitude 3 count in less than a week. Coso is not a mountain, and that is part of why most people have never heard of it. It is a scatter of 38 rhyolite lava domes, 14 basaltic centers, cinder cones, hot springs, and steaming vents spread across about 400 square kilometers on the eastern flank of the Sierra Nevada, at the northern edge of the Mojave. It sits about 64 kilometers north of Ridgecrest. Most of it lies inside the boundary of Naval Air Weapons Station China Lake, which means most of it is closed to the public. The last confirmed eruption there was about 40,000 years ago, and through all 208 of these earthquakes, the volcano alert level at Coso has stayed at normal. The aviation color code has stayed green. Neither has moved. The shape of this swarm is the part that separates it from an ordinary run of small earthquakes. Aftershock sequences have a very specific signature. They start with the largest event, then the rate falls off steadily and predictably, roughly as the inverse of the time elapsed. That decay pattern has been known for more than a century, and it is one of the most reliable behaviors in all of seismology. This swarm did the opposite. It built through Friday the 21st to 52 catalogued events. Then on Saturday it collapsed to 9, an 80% drop, almost back to background. Anyone watching the catalog on Saturday evening would have reasonably concluded it was over. Then, Sunday produced 116 earthquakes, more than double the first pulse, and it contained every single one of the swarm's 4 largest events. That is not decay. That is a driven process, something applying stress to the same patch of rock repeatedly with a pause in the middle. And there is no main shock anywhere in this sequence to decay from. The largest earthquake arrived 72 hours after the swarm started, which is the textbook definition of a swarm rather than a main shock followed by aftershocks. The magnitudes climbed with time, which is the reverse of what an aftershock sequence does. 1.93, then 2.98, then 3.29. Then at 59 minutes and 55 seconds past midnight Pacific time on Sunday morning, a moment magnitude of 3.96 at a depth of 2.83 kilometers. 80 seconds after that, a magnitude 3.36. 77 minutes after that, a moment magnitude 3.51. 3 of the 4 largest earthquakes recorded at Coso in all of 2026 happened inside a single 78-minute window in the middle of the night under a Navy weapons range. Now look at where they happened, because this is the detail that almost nobody is going to report, and it is the most revealing number in the whole story. Every significant earthquake in this swarm falls between 36.061 and 36.070 degrees north, and between 117.8375 and 117.8442 degrees west. Translate that into distance, and you get a box roughly 1 kilometer north to south by 600 meters east to west. 208 earthquakes over 5 days, all coming out of a patch of crust that would fit comfortably inside a large airport. The depths are just as confined. Setting aside 2 background events near Ridgecrest that are not part of this at all, every catalogued earthquake in the cluster sits between 2.26 and 3.51 kilometers down, and the clear majority fall between 2.5 and 2.8 kilometers. That is a depth spread of about 1,200 meters. What you're looking at is a thin, flat, shallow slab of rock breaking over and over. It is not a column. It is not a front moving through the crust. It is also worth being clear about how the energy in this swarm is distributed, because 208 is a headline number that flatters itself. Only 11 of those earthquakes reached magnitude 2 or above. About 197 of them were smaller than that, and a magnitude 4 releases something like 1,000 times the energy of a magnitude 2. Add all 197 of the small ones together, and they still contribute almost nothing. Sunday's magnitude 4 is essentially the entire swarm. And this is where the story turns, because there is one thing this cluster is conspicuously not doing. The earthquakes are not getting shallower. When magma, or magmatic fluid, rises through the crust, it cracks the rock ahead of it, and the earthquakes track that advance. The hypocenters climb toward the surface over hours and days. It is one of the clearest warning patterns in volcano monitoring. Nothing in the Coso catalog shows it. The depths on day 1 look like the depths on day 5. So the swarm is intense, it is structured, it is unusually energetic for this volcano, and it is sitting still. Before we go further, we need to deal with something that has been circulating since Sunday, because it is going to keep circulating. That largest earthquake was first issued as a magnitude 4.1, then it was revised down to 3.9, then it settled at a value that rounds to 4.0. Screenshots of all 3 numbers are online right now, and the claim attached to them is that somebody is managing the number to keep people calm. The revision is real. It genuinely happened in public, but the direction is wrong for a cover-up. A cover-up revises down and stays down. This one went down and then came back up. More importantly, the type of measurement changed along the way. The early numbers were local magnitude, which is computed from the amplitude of ground shaking on nearby instruments, and it is very sensitive to which stations happen to report first. The final published value is a moment magnitude, 3.96, computed from the actual physical size of the rupture, using 40 seismic stations with an azimuthal gap of 35 degrees and a location error of 18 hundredths of a second. Those are 2 different physical quantities measured 2 different ways. Expecting them to agree is like expecting a car's speedometer to match its fuel gauge, and the corrected value was published, time-stamped, and left sitting in the public catalog with its entire revision history attached. That is a strange way to hide something. There is one more piece worth knowing. The dense local seismic network at Coso is not run by the Geological Survey. It is run by the Navy, and it detects earthquakes down to magnitude minus 0.5, events thousands of times smaller than anything in the public feed. If anyone actually wanted to suppress an earthquake count at Coso, the public catalog is the least effective place on Earth to do it. Coso has magma under it. That is not speculation, and it is not the alarming part. It is the settled part. The Geological Survey's own language is unambiguous. Geophysical and geochemical studies detect a zone of partially molten rock underlying the center of the Coso Volcanic Field. Coso is one of only 7 volcanoes in California with confirmed molten rock beneath it, alongside Mount Shasta, Lassen, Medicine Lake, Clear Lake, the Long Valley region, and the Salton Buttes. The question is where that molten rock sits, and here the published science genuinely disagrees, which turns out to be the single most useful thing in this entire story. A 1980 study using distant earthquakes found a slow velocity body between 10 and 17 kilometers down. A 2003 study inferred a shallow reservoir at roughly 5 kilometers. Work published in 2005 and 2007 described a flat, sill-like magma body 20 kilometers long and 3 to 5 kilometers thick, sitting between 11 and 16 kilometers deep. And a 2022 tomography study, built for more than 137,000 seismic travel time measurements, imaged a large low-velocity body between 5 and 20 kilometers depth. Every single one of those estimates is deeper than this swarm. The shallowest credible top of the magma system at Coso is about 5 kilometers. The earthquakes are at 2.5 to 3. That gap, 2 kilometers of solid rock, is the strongest piece of evidence in the case, and it cuts hard against the frightening interpretation. These earthquakes are happening above the magma, not in it. There is a long-term trend that runs the other way, and honesty requires stating it. Thermobarometry on Coso's erupted rhyolite shows that over the last 600,000 years, the depth the magma erupted from has decreased. From about 10 kilometers, for the oldest samples, to about 5.5 kilometers for the youngest, 40,000-year-old material. The author's conclusion is blunt. As the reservoir has become closer to the surface, eruptions have become both more frequent and more voluminous. So yes, Coso is getting more dangerous over geological time. That clock runs in hundreds of thousands of years, and it has nothing to say about this week. Here is where this story stops being purely geological, because there is something else sitting directly above that magma body. The Coso geothermal field went online in 1987. It is 4 power blocks holding 9 30-megawatt turbine generators, rated at 270 megawatts total, drawing superheated brine from a network of more than 140 wells spread across almost 15,000 acres. 99 of those are production wells, running from 2,500 feet down to over 13,000 feet. 35 are injection wells. The reservoir runs between 200 and 328 degrees Celsius. Mass flow through the system exceeds 14 million pounds an hour. Now convert those well depths into the units we have been using. 2,500 feet is about 3/4 of a kilometer. 13,000 feet is about 4 kilometers. The entire swarm, all 208 earthquakes, every one of them between 2.26 and 3.51 kilometers deep, falls inside the exact depth interval where that plant has been pulling heat out of the ground for 39 years. And the plant is not what it was. Rated at 270 megawatts, running as high as about 302 megawatts net at its peak, it was down to 180 megawatts by 2010. A ratings agency downgrade in May 2012 cited, in its own words, geothermal resource depletion, noting the average net capacity had fallen to 170 megawatts. The operator today states the facility produces about 145 net megawatts. That is roughly half the output it was designed for, and it is the signature of a body of rock that has been substantially and permanently cooled. The short answer is yes, and anyone who tells you otherwise is wrong. This is not a fringe position. A paper published in the journal Nature in 2021, studying this exact location, states it plainly. 30 years of geothermal heat production at Coso depleted shear stresses within the reservoir, and thermal contraction of that reservoir initially induced substantial seismicity. Pull heat out of rock, and the rock shrinks. Shrinking rock cracks. That mechanism is real, it is published, and it is operating at Coso right now. The honest limits matter, though. The paper's central finding is actually about the opposite effect. It argues that decades of production have, on net, drained the stress available to drive earthquakes there. It is not a claim that the plant caused this particular swarm, and no operational data for last week has been made public, so nobody outside the operator can say whether anything changed in the injection schedule. What induced seismicity does not do is make a volcano erupt. Induced earthquakes are shallow, small, and confined to the volume that has been pressurized or cooled, which is precisely the pattern in front of us. To start an eruption, you would have to change conditions at the magma reservoir, 5 kilometers down at the absolute minimum. Between the wells and the magma sits a boundary called the brittle ductile transition, which at Coso is pushed up to about 4 to 5 kilometers. Below that line, rock stops cracking and starts flowing. Pressure changes in a network of cracks do not propagate meaningfully across it. The reasonable position is that the geothermal operation is very likely shaping the swarm and is definitely not going to erupt the volcano. We have seen Coso do something like this before, and the comparison deflates the alarm rather than feeding it. On the 4th of July 2019, a magnitude 6.4 struck near Ridgecrest, about 30 kilometers south of Coso. 33 3/4 hours later, a magnitude 7.1 followed on a different fault, crossing the first at nearly a right angle. Together, they tore more than 68 kilometers of surface rupture across the Mojave and triggered creep along 20 to 25 kilometers of the Garlock Fault. Coso responded by producing roughly 600 earthquakes of magnitude 1 or greater per day, about 1,600 in the 2 days following the 8th of July alone. 12 of them exceeded magnitude 3, and the 2 largest were magnitude 4.1. Set that against this week, 208 events over 5 days, largest magnitude 3.96. This swarm is running at roughly 1/15 the daily rate of 2019, and its biggest earthquake is slightly smaller than the 2 biggest from back then. 7 years on, Coso is not building toward something. It is doing a much smaller version of what it already did. But there is a fight in the literature about 2019 that matters enormously for how much you should trust the number 208. That same Nature paper says that Coso, sitting in a zone where stress changes, should have triggered aftershocks, produced none. No aftershocks were observed there. A separate peer-reviewed paper by a geological survey seismologist, working from the Navy's dense local catalog instead of the regional one, found the opposite. Coso behaved identically to the surrounding area, and the apparent absence was simply the regional network failing to see the earthquakes, because that shallow, brittle ductile transition distorts how the crust there is sampled. One paper says the earthquakes were not there, the other says they were there and we could not see them. Both are peer-reviewed. Neither has been retracted. That dispute leads directly to the thing that should actually concern you about Coso, and it is not the magma. The California Volcano Observatory has a published decision framework for exactly this situation, and the logic is clean. Magma pushing into the subsurface has to shove rock out of the way, so it produces deformation. The ground swells. The gases riding with it have to escape somewhere. If you do not see either of those, the source is either too deep to matter or it is not magmatic at all. Deformation is the discriminator. It is the measurement that settles the question. Now count the instruments. There is one seismometer operated by the Geological Survey near the Coso Volcanic Field. It was installed in 2001. There are 3 GPS receivers making up the continuous deformation network. They went in during 2000, 2005, and 2006. There are no tilt meters at Coso. There are no strain meters. There's no gas monitoring at all. 3 receivers, the newest of them 20 years old, covering 400 square kilometers of volcanic field with a body of molten rock underneath it. For comparison, Long Valley Caldera has 46 GPS receivers and 9 tilt meters. That asymmetry is deliberate, and it is defensible. Threat ranking is not a popularity contest. It is a 24-criterion assessment. Long Valley scores 129 and ranks 18th of 161 American volcanoes. Coso scores 55 and ranks 72nd. Long Valley produced a super eruption 760,000 years ago that moved something on the order of 650 cubic kilometers of rock. Coso's most productive stretch in 6 million years produced about 35 cubic kilometers total. Long Valley has a town at its edge. Coso has 370 people within 10 kilometers. Coso is monitored roughly in proportion to what it can actually do. The reassurance we are being offered this week is real. It is also thinner than it sounds, because the instrument that would tell us otherwise is 3 receivers wide. So where does that leave us this morning? The defensible reading is that this is a vigorous but ordinary swarm in an extensional step over between 2 strike-slip fault systems, very probably driven by pressurized hot water forcing its way through a fracture network 2 to 3 kilometers down inside a geothermal reservoir that has been actively cooled and drained for 39 years. Pressurized water lifts the 2 sides of a fault apart, just enough to let it slip under stress that would otherwise hold. That mechanism produces exactly what we saw. Bursts, a gap, a bigger burst, and magnitudes that climb instead of decaying. No magmatic signal is present in any data stream we have. A normal alert level is the correct call. There are 5 things that would change that assessment, and they are worth knowing because they are what the observatory itself is watching for. The first is hypocenters beginning to migrate upward, or a new cluster opening west of the current one. The Geological Survey states that future eruptions are more likely in the western half of the field. The second is a change in the character of the signals. Long-period earthquakes, the broad and wobbly kind produced by fluid moving in a crack, or continuous harmonic tremor, replacing the sharp, high-frequency snapping we are seeing now. That transition is what preceded Mount St. Helens in 1980 and again in 2004. The third is any inflation on those 3 GPS stations. Coso has been sinking, not swelling, for as long as we have been able to measure it. About 3.5 centimeters a year through the 1990s, and up to 15 millimeters a year more recently. Any reversal would be the single observation that moves this from hot water to magma. The fourth is new or intensified steam and gas at Coso Hot Springs. The fifth is an information statement from the observatory, which is the deliberate first step before any alert level change. None of those 5 has happened. The most recent Coso-specific notice on file is still dated July of 2019. Watch the catalog over the next 2 days. Yesterday, the count stood at 15 events, including a magnitude 2.73 just before 1 in the morning. If Coso produces another 100-plus day, or anything above magnitude 4, this swarm stops resembling anything in its recent record. If it fades, this was hot water, finding a new path through cracked rock. And the most interesting thing about it will remain the fact that we needed 3 aging receivers in the desert to tell us so.